Okay, so my name is Barbara Giles, and I work at NASA headquarters in the Science Mission Directorate. And if you were here yesterday, you heard me give an introduction to how the Science Mission Directorate is organized. I'm repeating a few of those charts here just for those who weren't here yesterday. And those of you who were, you'll be bored for a few minutes, but I'll try to go very quickly. So let's go to the first slide. What I want to emphasize is what I'm talking about here in this talk is just the part of science that NASA supports in the Science Mission Directorate, and in particular these 4 areas of science listed at the bottom of the chart. That is the Earth science system. We want to meet the challenge of climate and environmental change. We seek to understand the sun and its interactions with the Earth and solar system. We want to look at the history of the solar system and the potential for life elsewhere. We want to discover how the universe works, how the universe began and evolved, and whether we are alone. The next slide talks about the strategy the Science Mission Directorate has in place. We write this down and we really do follow it. So I wanted to emphasize that what we're seeking to do is to answer big science questions. We actually write it this way in the science plan because it's really not about making incremental progress or monitoring, we do have an applied program, but the real focus is on answering what we consider to be big questions, for which the view from space is the defining contribution. If there's an experiment that is just as well done from the ground, we tend to leave it to be done by those agencies that use ground observatories. We do this by dividing our work into programs, and that's really important to understand. We have a lot of different programs defined to do this science, and they all have their own budget to stay within. And so as we go forward with these charts, you're going to see that there are opportunities to propose experiments to the space station from all of these different programs, and those opportunities are going to come out at different times. So today I'm going to give you a list of what opportunities are open right now, but also give you a map so that you can find other opportunities that may open in the next few years. Let's go to the next slide. We make our decisions according to these priorities, and we want to make substantial progress on what we call decadal surveys, and I have a chart on that in a minute. You're going to want to watch the decadal survey process. Because as our measure of success is we want to make progress across the entire scope of science covered by SMD. Our investment choices are based on scientific merit. That is certainly we have our technical considerations. Is this a feasible mission? Is it ready to go? But the absolute highest priority is scientific merit, which we evaluate via peer review. The next chart talks about, these are the 4 areas of science the Science Mission Directorate supports: Earth science, planetary, astrophysics, heliophysics. This is about a $5 billion a year program. About $1.8 billion is devoted to Earth science, about $1.5 to planetary, about $1 billion to astrophysics, and about $650 million to heliophysics. The next slide is, this is a resource you can go to that explains the structure that I'm talking about, explains all of the programs supported in the Science Mission Directorate. And there is a new science plan, 2010, that should be posted to this website. If you go there and it's still the 2006 plan, keep checking back. It's about to be posted, if it's not already. And so this is your guide to know what kind of missions, what kind of science is the highest priority at this time that we will be supporting. The next slide shows, and in that science plan, I just want to go through these quickly. We won't read these all out loud, but these are the highest priority science questions that are in that science plan for the next few years, the next 10 years that we will be supporting. So in earth science, these are the questions. Next slide are the questions for planetary. The next slide is for heliophysics. The next slide for astrophysics. Hopefully everyone can find themselves in these questions. The next slide is a list of all of those programs. So when you look at those science questions for any given division, these blocks are the programs in place and thereafter answering those questions. And any one of these programs, there are flight programs, the majority are flight programs, but there are a few that are technology development, a few that are just research, using perhaps the flight programs. But any of these could, at any given time, put out an announcement for investigations that could be hosted on the space station. And in fact, I'm going to tell you today about open announcements that are going to map back to 7 of these blocks. And so keeping up with that, I know, is going to be difficult, but you're going to have that map, you'll have the science plan, and I'm also going to give you the address to the place that you can sign up for announcements. If you sign up for announcements, you can't miss them. And must not be on this slide, though. Next slide. Oh, this is the other thing I want to talk about. In addition to knowing the landscape of what programs are doing what science, so you know where to look for your particular interest, the other thing you need to understand is what these programs already have in place, so that you're not looking to duplicate. You want to be doing something that is new, answering big science questions, don't want to do incremental. And so this is just a map of all of the missions that these divisions are already supporting. The Science Mission Directorate has right now 87 missions supporting 100 spacecraft. 40 are already flying an extended mission. Actually, some of those might be aging out soon. Don't know. You want to keep up with that. Some in primary mission. Some are just being built now, 17 in implementation. There are 12 in formulation. And at the bottom, there's another 10 or 11 we'd have to count that are in the planning stages to join the big chart. And so there's already a lot going on, so you're going to want to know how your particular interest, how your particular concept that you may want to propose, how that might fit into the plan for that particular program. Let's move on to the next chart. Certainly, community participation is at the core of everything we do. The science plan, when we decided what were we going to do next, that started with community roadmaps and those decadal surveys that the National Academy does. And what's really interesting, I think, about this is that you'll notice that our plans for the future don't necessarily change with every administration. And the reason for that is that, at least for a while, a few decades, every administration believes that this National Academy decadal survey process to do planning by the top scientists in our nation on a 10-year basis is the way to make decisions. And so when you see our science plan, you'll be able to trace it back to the decadal surveys. The next chart shows which are these are the titles of the decadal surveys for each of those science divisions. And you'll notice that in earth science, there's kind of a recent decadal survey, 2007. So that's in effect for a while. Planetary, 2002. Heliophysics, 2003, 2001. And if you hit the button one more time, there's some new surveys that are going to be coming out in the next few years. And so you'll want to watch for those new surveys and how the next science plan may change. So over the next 3 to 5 years, the landscape as far as the top science priorities may change a little bit, and you'll want to map that as time goes on. The next chart. Oh, good. Now we're getting to the opportunities themselves. And I'm going to tell you about 2 different kinds of opportunities. Both are BAAs, but I want to talk about AOs, Announcement of Opportunities, and then in a minute, which is why I graded out, the NRAs. The main difference between the two is that AOs tend to be for much larger projects, $55, $90 million experiments that involve hardware sent to space. The NRAs are more research-oriented and include smaller projects, even to the ISS, on the order of hundreds of K to a very few millions of dollars. So as we look at this, just kind of go big, small in your mind. But you'll want to look for both AOs and for NRAs in the announcements in the future. Now, the first opportunity that we have is in the next slide, which is the Explorer program. And we just released a draft opportunity. We released an AO both for full Explorer missions, but also for missions of opportunity, including experiments that might be deployed at the space station. And so you go, oh, is that a draft? That's not a real one? And I'm going, you're right, it's a draft. In the Science Mission Directorate, we very often release drafts first, get feedback from the community, and then we release it in a way that everyone's happy with. So we released that draft on June 22nd. And this address at the bottom is a site that, if you're interested in this opportunity, you want to go to this site on a regular basis. People ask questions, we give answers, all the updates are there, new announcements. So it's a resource to keep checking back on a regular basis. The next slide. The Explorer program is about astrophysics and heliophysics only. There's another program for earth science I'll talk about in a minute. And so these are about understanding the sun, effects on the earth and the solar system, discover the origin, structure, evolution, destiny of the universe, search for Earth-like planets. That is the scope of the science that can be proposed to this particular opportunity. The next slide. The cost cap for these missions of opportunity is $55 million. So everything that for a particular experiment that the Science Mission Directorate has to pay for needs to fit in the $55 million. I guess I understand that the access to the space station, that may come from somewhere else. There are different types of missions of opportunities here. I'll let you look up the definitions of all of those, but you'll notice that one of those is investigations on the International Space Station. So this isn't a space station only call. It can be for any kind of mission of opportunity, including instruments on spacecraft hosted by other countries or other national agencies. It is very competitive. And the next slide may take more wind out of our sails in that we know that it costs a great deal of money and investment to write these proposals. And so we want to be very clear on what this program can support. And the current budget within the Explorer program is sufficient to select at least one full explorer mission and another full mission or one or more missions of opportunity. The full missions are capped at 200 million. Our intent is to select at least one of those, and then we will select either a second mission or some missions of opportunity. That's based on our current understanding of the budget runout. When the AO is released, we hope to have some new information, and we will keep working this statement so that you know what the competition landscape is. The next slide. The schedule for this, the release of the final AO, we intend to be late summer, early fall 2010. I do use the astronomical definitions of summer and fall. We will have a proposal conference about 3 weeks after that. That's a conference in which we explain to you very carefully how your proposals will be evaluated. We believe that helps you write a better proposal if you know the evaluation process and criteria very well. The proposals will be due about 90 days after the release. I've already had an official Q&A to the website that says, do you really intend 90 days, and are you going to spoil our holidays again, like you did the last time? And okay, I'm just going to announce, we probably will spoil your holidays again this time. Okay, I haven't quite put that on the website officially yet. Now, selection, we usually do a down select process. That'll be summer, and then the final selections will be a year after that. Let's move on. That's for heliophysics, astrophysics. Are you interested in earth science? The earth science program coming up that you're going to be interested in is called Earth Venture, and this is something that some of the increases that President Obama has brought to the earth science community is coming into play. And you'll see that next year, let's see, beginning in late fiscal year 11, there will be an annual instrument solicitation that are $90 million. That'll be approximately the cap for a 5-year development and for launch. And these are missions of opportunity, again, that include the space station, not necessarily limited to. Some people have the idea that commercial ComSats would be the way to host some things as well. So this venture class, it looks like, will be a nice yearly opportunity for very large experiments. The next slide. This is more information on this. These are fresh slides, and it kind of has some nice information here. You just really, I'll let you read that. Nothing too obvious things. Okay, next slide. Oh, okay. So those are the two larger opportunities that we have either about to open in the next year. We do have some research and NRA opportunities that are open now, and these tend to be smaller awards, well, $50K to a few million. When you're using experiments that may already be in place to do new science, the average award is about $100K. If you're going to deploy a smaller experiment, say on a sounding rocket, on a balloon, or something that could be smaller, but on the space station, they tend to be up in the few million mark. The next slide. The types of programs that this NRA supports is, of course, fundamental research. There's instrument and technology development. We call it guest investigator data analysis. If there's already equipment on the space station, for example, you would propose toward the data analysis and guest investigator types. Participating scientists. Sometimes there are experiments flown by other countries, and you can be supported to be a participating scientist on someone else's space station program. And then there's other stuff. Okay, next slide. This is the announcement you're going to want to go to understand how to respond to this NRA, the ROSES NRA, with respect to space station research. And so this is the number right there, that NNH10ZDA. You're going to want to look that up, because this amendment number 11 has quite a bit of text to point you to where you need to go among all of those different blue blocks we talked about under the Science Mission Directorate. Which program do I go to for my particular kind of science? This amendment number 11 is your map to do that. And in fact, the next slide, well, okay, in a second it will. Let's see, we'll get there in a minute. So we've determined that there are good ideas that can utilize the International Space Station. As we've seen here in this workshop, there's lots of great places to put it. Externally, here there's external places listed. There are launch opportunities. And we also, there's the observation window. So this is text that comes out of that amendment number 11. This is what we have been hearing about, all of these places that we can deploy experiments. The next slide. And so when we're talking about proposals to the Science Mission Directorate, we really are seeking experiments that take advantage of the station's unique capabilities. If you have an experimental concept that is better developed, deployed elsewhere, then we really should do it elsewhere. But if your concept is something that really advances the science that this directorate is interested in, and it really should be done from the station, these are the opportunities to propose. And so you really do need to have a complete plan for doing that in your proposal. You really do need to do your homework and identify a specific location that really meets the intent of your science experiment. And think about the experimental method in that, what is the big question you're trying to solve? How does your experiment do that? You really do need to design that experiment from end to end. How will you use the data later to answer that science question? Proposals to the Science Mission Directorate really have to cover the full scientific method. And there's a note, life in microgravity science, that's not through this announcement. We're going to hear about those in a few minutes. Next slide. Here's where in that announcement it tells you where within the broad ROSES NRA you can find your particular type of science. If you're doing Earth science, it is Appendix A27, even though it doesn't look like it from that title. Okay, that looks like the commercial platforms. But Appendix A27 has been expanded to include the space station in the Earth science area. So go to A27 for Earth. For heliophysics, you want Appendix B3 and B4, depending on whether you're Earth-based or sun-based. In planetary, it's Appendix C5, and in astrophysics, it's Appendix D3. So here's your map, back to all of those different programs. And so these announcements is, let's look on the next slide. Is the next slide the due dates? Let's go to the next one real quick. Yeah, here are the due dates for those particular elements, and you'll notice that some of them have passed, but you'll look for those to open up again next year around the same time. So you have time to prepare for those, where some of the others, it's a much shorter time to do. Go back one. We also want to mention that if there is a way to do outreach activities connected with Science Mission Directorate goals, using equipment already on the space station, and you like doing EPO, this is open to those kinds of ideas. So this is an opportunity for those of you who like to do outreach. So the next slide we've already done. Those are the due dates. And remember that this is something that comes up annually, and it is going to be annually opened for space station type proposals. The next slide, questions on this. Paul Hertz in the Science Mission Directorate is the chief scientist. And I'm actually one of the scientists in the heliophysics area, and I will be working the Explorer program announcement. Let's see, so there's a map for more questions. Let's see, is that it for the announcements? Let's see. And there's always a reminder that in addition to deploying hardware, we also support many scientists to do research using the open data sets that are already there. So please look for those research announcements. We consider that to be as important as fielding the missions themselves. Next. Guidelines. Oh, this is a reminder that when we're starting to put together projects, and we're going to involve international partnerships, we do encourage partnerships, but we also have to be very careful about how we go about that. And you'll want to contact, before you start negotiating partnerships with other countries, you'll want to contact the Office of External Relations at NASA headquarters to help you do that in a way that will make you successful, because all arrangements have to conform to the NASA policies. And it's really important to manage expectations when you first start discussions. And there are, for each of the divisions, there's somebody at headquarters who's just assigned to do that, and they'll be willing to help you open up discussions, assist you with discussions. Next. And this is the end. Of course, when it comes to the Science Mission Directorate and answering the big science questions, we're always looking for a new way of doing things, a new way of looking at things, and so you are here. So this is an actual picture from Cassini, believe it or not. And look, there's the Earth way in the background. Thank you very much. I'll be glad to take questions.